So in this video I want to consider the definite integral, and on the first slide I just want to briefly go over the notation. So this is an example of a definite integral, and this is the integral sign, and this tells us that we are looking at an integral. If we have a definite integral like this one, we have a value at the bottom and a value at the top. And the value at the bottom is called the lower limit of integration. The value at the top, in this case b, is called the upper limit of integration. After this, we write a function, and this is the function that we are going to integrate over. And this is called the integrand. So the total result is the integral. The function we integrate over is the integrand. And we have to ask ourselves, what is the variable that we're going to integrate over called? And this is shown by this. Here it's dx, and that's called the measure, and it tells us that we are integrating over x. If we were to have, say, d theta, we would be integrating over theta. So that's the notation, and what I want to do now on the next slide is to talk about the graphical interpretation of a definite integral, and having done that, we're going to calculate an example. So, to understand the graphical interpretation of this definite integral of some function f of x from a to b, what we do is we draw a sketch of the integrand, the function which we're going to integrate, and we have to draw it such that we can see both the lower and the upper limits of integration. So here's my lower limit, here's my upper limit, and I'm assuming here, by the way, that a is less than b. In other words, on this axis a is to the left of b. Okay, with that assumed for the moment, if this is our graph, we have the following interpretation. What we do is we draw the line from x, on the x-axis from x is a, up to our graph. So in other words, we draw this line here. And similarly, from where x is b crosses the x-axis, we continue it up also to the graph. And then we notice all the area trapped between this line here, the x-axis, and our curve. So the first area that we're going to have is an area that looks something like this. Okay. Then we have another area, which is this area which is below the x-axis. That's this area here. So I'll just draw that here. And then we have a third and final area, which is also, just like the first one, above the x-axis. So all we've done so far is we've drawn our integrand, the function we want to integrate, and we've marked all the area between the line x is a, the lower limit, x is b, the upper limit, and the x-axis and the curve of the function that we're integrating over. And the way I've drawn it here, we've got three areas here. Two of them I've shaded in yellow, those are the ones above the x-axis, and this one here I've shaded grey because it's below the x-axis. So our interpretation of this integral is going to be in terms of these areas, and let me call the first area here, let me call this area, say, A1. Let me call the second area here, let me call that A2, and let me call the third area here A3. And our interpretation of this definite integral is that it's going to be A1 minus A2 plus A3. In other words, this is a particular example of a general rule, and the general rule is that when you sketch the integrand, as we've done here, and you find the area trapped between the curve of the integrand and the x-axis, and that might be above the x-axis as here and here, or it could be below the x-axis as here. All the areas above the x-axis give a positive contribution to the integral, and any area below the x-axis gives a negative contribution to the integral. All areas are of course positive, but this area here, because it's below the x-axis, gives a negative contribution to the integral. So that's the general graphical interpretation of what a definite integral means. So what I want to do on the next slide is to calculate an example, and it's an example where we're actually able, using geometry, to work out the area above and below the x-axis. So we'll do that on the next slide. So the example we want to look at is the integral from 0 to 3 of the function 1 minus x integrated with respect to x. And to calculate its value, which we can do for this simple case, and to understand generally what it is, it's helpful to sketch the integrand. So I draw my axes, and the integrand is the function we're going to integrate. Here it's 1 minus x, a straight line. So it starts here, crosses the x-axis and carries on down, and this is y is 1 minus x. So when x is 0, our function has value 1. It crosses the x-axis, this vanishes when x is also equal to 1, and at our maximum value that we're interested in, x is equal to 3, our function is the integrand is going to have value 1 minus 3, so it's going to be down here at minus 2. So let me just draw the line x is equal to 3 until I bring it down to where it crosses our function, our integrand. So our interpretation of the definite integral tells us the following: that the integral from 0 to 3 of 1 minus x integrated with respect to x is going to be this area minus this area, because this area is below the x-axis. So let me give these areas names. I'll call this area A1 and I'll call this area A2. So what we have is that our definite integral is A1 minus A2. And both of these areas are triangles, that's why it's going to be easy to calculate them. So let's just recall as well that the area of a triangle is equal to a half the base of the triangle times the height of the triangle. And looking at our graph, we can see what the base of this triangle is and what its height is. We can see the base of this triangle and we can see the height of this triangle. So we're going to be able to calculate the areas, and thus we're going to be able to calculate the integral. So let's first of all just calculate the areas separately. A1 is going to be a half the base times the height. We look at the triangle, the base is here from x is 0 to here x is 1, so the base is 1, and the height is here from y is 0 up to here y is 1, so the height is also 1. So therefore we have a half times 1 times 1, so that's very easy, it's just a half. Similarly, A2, the area of the other triangle, is going to be a half times the base times the height. The base of this triangle is from x is 1 to x is 3, so the base is 2 units, and the height of this triangle goes down here from y is 0 to y is minus 2, so the height has got value 2 units, so this is 2 times 2. So we have 2 times 2 times a half, so the answer is A2 is going to be 2. And the height of the triangle is of course plus 2 here, but the fact that we have a minus sign here, this is the reason why this sign here below the x-axis contributes negatively, but we'll see that in a separate video. So we've calculated A1 and A2, and from this we can read off our final result, and what we conclude is that the integral from 0 to 3 of 1 minus x with respect to x is A1, which is a half, minus 2, which is A2, and that is minus 1.5, or put perhaps slightly more nicely, minus 3 halves. So that's our final result for this integral, and we can calculate it by calculating these areas, but almost immediately, just looking at this example, we realize that it had to be negative. And this is a good way of spotting errors in any calculation of a definite integral. Quite often you can see that the integral must be positive or must be negative or might vanish. So that's a very useful thing to look at, and this is our definite integral interpretation. And with that, I'll stop this video.